This video illustrates how you can use VBA along with the at-risk XDK to import data into Excel and then use it for a simulation. Specifically, it shows how you can import data from a database or from a text file into Excel and then use at-risk's fitting tools to fit distributions to the data. The code illustrated here is in the at-risk XDK fit access data and fit text file data example files, and you can view them for more details, but this video explains how it all works. I will start by showing how you can import data from an access database into Excel. This has nothing to do with at-risk per se, but it is useful if you plan to fit at-risk distributions to external data. The data for this example is in the demand data access file you see here. The database contains weekly demands for each of 4 products. There are 2 tables, demands and products, related as shown here through the product ID key fields. Demands for products. Here is the at-risk simulation file. All of the logic is set up except for the demand distribution in the blue demand column. The idea is that the user will choose a product from cell C10 where information about the 4 products is listed above. Then when the button is clicked to run the main macro, the database data for the selected product will be imported into the now blank data sheet. Distributions will be fit to the data. The best fitting distribution will be entered in the blue range. The simulation will be run, and summary statistics of the 2 at-risk outputs will be entered in rows 13 and 14. In fact, I will now click the button so that you can watch everything happen. Obviously, it is very fast. As you can see, the best fitting discrete distribution for the demand data for drills is Poisson with mean 25.361. Here is the imported demand data. Let's take a look at the code that makes this work. Here is the main run app macro, the one attached to the button on the model sheet. From the on-air line down, this code is all about at-risk. It fits the data that have by now been imported into the datasheet. It enters a formula for the best fitting distribution into the blue range of the model sheet. It runs a simulation with 1,000 iterations, and it enters summary statistics of the outputs into selected cells. None of this is new. It has been discussed in previous videos. The new part is the import data subroutine called to import the data from Access. It is called right here. This takes a product ID and it returns a range where the data have been placed. Here is the import data macro. This type of code, used by many programmers to import data from any number of database packages, uses the Microsoft ActiveX Data Objects, or ADO, library. As you can see from the reference list, the references now include the Microsoft ActiveX Data Objects library, as well as the usual 2 at-risk references. This new reference to ADO provides access to 2 important objects, the connection object and the record set object. The connection object enables you to create a connection to a database, and the record set object holds the results of a query on the database connection. This code will probably be unfamiliar if you have never accessed database data before, but the good news is that you can use almost the same code every time you import database data. Here are the steps. You declare the objects as new instances of ADODB or ADO database objects in the declaration lines. You define and then open a connection to the database. The details in these lines vary from one database package to another. They are simplest for Access because it is a desktop-based database package, as opposed to server-based packages like Oracle or SQL Server. You write an SQL statement to indicate exactly which data you want to import. Of course, this requires some knowledge of SQL, the query language for databases. And in this case, I'm requesting data from the demand field in the demands table, filtered by the desired product ID. Next, you open the record set based on this SQL statement and the given connection. Next, you step through the record set one line at a time until you reach the end of the file, EOF, and you transfer data in any desired fields, in this case the demand field, into Excel. Finally, you close the record set and then close the connection. Again, this code is quite general. If your data were in an Oracle database, for example, the only lines you would change are the two that define the connection. These two. Your database administrator can help you with the required details in these lines. It is possible that the data you need to import reside in a plain vanilla text file rather than in a database. As I will now illustrate, the same basic program still works. Only the import data macro needs to be changed. Here is the same demand data in a text file. Each row after the first row contains the demand for a given product in a given week. The data are tab delimited. Here is exactly the same model sheet and blank data sheet you saw earlier. The only difference is that the data will now be imported from the text file. Here is the new import data macro. Note that no special references are required in this case, except of course for the references to the at-risk libraries. The code is fairly straightforward, and again the good news is that essentially the same code can be used to import the data from any text file. Here are the steps. You first reference the file. Second, you open the file for input as number 1. If you needed to open other text files, you would open them as number 2, number 3, and so on. This file is opened as input because you are reading from it, not writing to it. Third, you again loop through the lines of the text file, one at a time, until you reach the end of the file, EOF. Each time through the loop, the first line reads the next line of the text file and stores it in the data line variable. Then the very handy VBA split function parses the data in the line into a data item array, using the tab character as the delimiter. This array is zero-based, so its indexes for this example are 0, 1, and 2. The data item with index 2, that is the demand, is then transferred into Excel. Note that the first line of the text file is skipped because it contains non-numeric headings. Finally, the text file is closed. I will now run this application, this time for stepladders. As you can see, it runs very quickly. Obviously, databases and text files are common sources of data, but they are not the only sources. A primary source not yet mentioned is the web. For example, you might want to import stock price data on a daily basis from a financial website. This is definitely possible, at least sometimes, but the required import data macro would depend heavily on the particular way the website is set up. The Excel object model has a query table object for importing web data, and you might want to check it out. However, this might work and it might not work. The problem is that you, as a programmer, are completely at the mercy of the website developers. Sometimes they won't even allow you to import their data. As this video has illustrated, you are obviously much more in control if your data resides in a database or a text file.